For the first 4 problems, go to your glossary in the back of your book or to the notes that you took in class. For choosing nominal, ordinal, interval, ratio, nominal and ordinal are usually words. Interval and ratio are usually numbers. For nominal, nominal is a name. Ordinal gives things an order or ranking. Also, I like to think first, second, third. My shortcut for telling the difference between interval and ratio, you can read more about this in your book, but I just remember that I always guess ratio unless it's temperature. Temperature is interval. And everything else is usually ratio. There's some exceptions that you can look at in your book or in your notes. Let's get to the problems. Part A, pages in the 25 best-selling mystery novels. Pages is a number, so that's ratio. Rankings of golfers in a tournament. Ranking is order, first, second, third, so that's ordinal. C, temperatures inside 10 pizza ovens. That's a number, that's temperature, so interval. Weights of selected cell phones. That's a number, so ratio. E, salaries of the coaches in the NFL. It's a number, so ratio. Times required to complete a chess game. That is a number, so ratio. Ratings of textbooks. Poor, fair, good, excellent. That's words, so either nominal or ordinal. And since there's a ranking to them, poor is worse than fair. Excellent is better than good. It's ordinal. It's first, second, third. Ordinal. H, number of amps delivered by a battery charger. It's a number, so ratio. Ages of children in a daycare center. That's a number, so ratio. Categories. That's a name, and there's no ranking to it, so that would be nominal. Qualitative means shows a quality. Quantity is a number, or how much. So part A, marital status of nurses in a hospital. That's a quality. Time it takes to run a marathon. That's a time, a quantity, how much. Weights of lobsters in a tank in a restaurant. It's a number, quantity, how much. Colors, that's a quality, not a number. Qualitative. Ounces of ice cream, that's a number, how much. Quantitative. Discrete variables are counted. They are whole numbers. Continuous are measured. They often contain fractions and decimals. A, number of pizzas sold by Pizza Express. That's a counted thing, whole numbers, so discrete. B, relative humidity levels in operating rooms at local hospitals. That's measured. It could contain half a degree or a fraction of a degree. Number of bananas in a bunch. Not at several local hospitals. That is discrete. Can be counted, whole numbers. Lifetime in hours of 15 iPod batteries. That's measured. It's continuous. It could contain fractions or decimals of hours. Weights of backpacks. Continuous. Measured. Could have fractions of weights. F. Number of students each day who make appointments with a math teacher at a local college. Discrete. That's counted. They're whole numbers. Blood pressures of runners in a marathon. The book will tell you C, continuous, because they are measured. I would also accept discrete, since most blood pressures are whole numbers. Class boundaries. In class, I said to go 0.5 above and below each number to find the class boundary, which works well for A and E. So the class boundaries for A, 0.5 below, would be 35.5 to 0.5 above, 36.5. And part E, 4.5 to 5.5. The ones with the decimals are a little trickier. If you have one decimal place in your answer, instead of going 0.5 above and below, you would go 0.05 above and below. So your correct answer would be 105.4 minus 0.05 and 105.4 plus 0.05. Again, one decimal place, you go plus or minus 0.05. So your answer would be 72.55, 0.05 below this number, and 72.65, 0.05 above this number. If you have two decimal places, you'll go 0.005 above and below your number. .27 minus 0.005, and on the other end, plus 0.005. To set up a categorical frequency distribution, you just make one row for each of the options, tally up how many responses each thing gets, and then add up your frequencies. There are 4 A's, 28 M's, 6 H's, 2 S's. There are your frequencies for your categorical distribution. For me, the hardest part about this problem is knowing where to start. You have to know how big to make your class sizes. To do that, start with your range. That's your high value minus your low value. In our case, the high value is 52 and the low value is 21. Subtract that and get 31. That's our range. Our problem told us we needed 5 classes. So we'll divide our range into 5 equal groups, which gives us 6.2 per group. When you're figuring class width, always round up. So 7 will be our class width. Your class limits, start with your lowest number, 21, and use your class width to find the beginning of the next class, 21 plus 7. Continue adding 7 to find the beginning of each class. A common mistake is to put the 28 here. That's not how it works. Class width goes from the first class limit to the second lower class limit. Now, fill in the end of your class. You know the next class starts at 28, so this one must end at 27. Class boundaries. 0.5 below this number and above this number, since we have whole numbers. I'm going to stop the recording to tally. Once I have tallied, I count up the frequency by counting up my tallies. To find the cumulative frequency, I take 6 plus 9 plus 5. It's a running total. Plus 7 plus 3. This number, 30, should always match up with the total number of participants in my study, data points in my study.